Hi guys, welcome to Geography Science Academy, just a minute series where every minute counts in locking the secrets to master your board examination. Today we have come up with how to draw the structure of fructose. As we know, it is very important for the upcoming board examination. So in the last video, we have discussed the easy trick to draw the glucose structure. So fructose structure is not very different from the glucose. So if you remember this, focus on this third finger, okay, first, second, third. Third finger you have to focus. And we know in glucose, first we will draw the structure of glucose from the last video. So you can see this, there are 6 carbons in the glucose. 1, 2, 3, 4, 5, 6. Now, in this 6 carbon, focus on the third one. Okay, if you see this third finger, so third carbon, the OH was on the left, the rest, all the chiral carbons, the OH was on the right. Now we know the last carbon was the 1 degree alcohol, that is CH2OH, and the first carbon was the aldehyde group. Okay, CHO group was there. Okay, this was the structure of glucose. Now, when we draw the structure of fructose, it is not very different. So, we know glucose and fructose both are functional isomers. The glucose is aldehyde group, fructose contains a ketone group. So, let's draw 6 carbons again because the chemical formula of both glucose and fructose are same. So, 6 carbon, this also has. Okay. Now the difference is here the first carbon was having the aldehyde group. Here the second carbon is the ketone group. So the first carbon is same as the last one in the glucose. That is CH2OH, 1 degree alcohol. Last one is also 1 degree alcohol. Now what about this? So again focus on the third carbon. In the third carbon the OH is on the left and rest all everywhere the OH is on the right. Now what we will do now? Now we have to see, in the second last carbon, the oxygen lone pair, okay, is there. And here, if you see, this oxygen is more electronegative, so it will form a partial negative and there will be a positive. Now, what will happen? We will take the second last, oxygen lone pair, which will donate on this carbon, and this hydrogen will go to the O minus. Okay. Now the question arises, sir, the OH was available on the last carbon also, in the fourth carbon also, but why did you choose the second last, the fifth carbon OH group? The reason is because here we will make a 5-membered ring, and we know 5-membered ring is a highly stable ring. Like in glucose, there also we took the second last oxygen, if you all remember in the last video. Why did we took the second last oxygen only? Because it made the 6-membered ring, and we know 6-membered ring is a highly stable ring. Okay. Similarly, in fructose, the highest possible ring is 5-membered ring. That is why we are taking the lone pair from the second last oxygen OH group. Okay. So now what will happen after this? What structure do we get now? So the structure we will see here. So you can see, focus on this carbon now. So this carbon has a OH now because this O took the H. So there is a OH. And what is on the left? On the other side, there was 1 degree alcohol, that is CH2OH. So this is your first carbon now of the ring. Now, after this, there the OH is on the left. Okay, here the OH is on the right on the next carbon. Now this is very important. In this one, if you see, hydrogen is on the left, but here the oxygen is bridging with the first carbon. So here we will write the oxygen which will bridge with this carbon. You can see, and the last one will be as it is, CH2OH. Now understand, this was the Fisher projection and we are making into a ring, that is a Hayward projection. So in the Fisher projection, okay, what you will see, now you can see this looks like a 5-membered ring. Okay, let me highlight this. So 4 carbon, okay, and 1 oxygen. So it makes a 5-membered ring. Okay, so now let's convert this into a ring-like structure. So first of all, to do that, let's erase this one, the glucose structure. So for the structure of glucose, you will find the link, okay, below, and you can click on this and you can find the easy way to draw the glucose structure. Now let's make it into a ring. So it's a 5-membered ring. So we'll make a pentagon where oxygen will be in the center. You can see this oxygen, and there will be 4 carbons. Now, all the horizontal bonds will change into vertical. In this Haworth projection, we will make a vertical bond. Now, remember, whatever is on the right, it will be below. Remember, right means below. So, whatever horizontal is right, in vertical, in the ring structure, it will be below. And left means it will be above. So look at this first carbon. Okay, OH is on the right, so we'll write it below. In the second carbon, OH is on the left, so we'll write it above. Then in the third one, again OH will be below. And in the fourth, the bigger group is placed above, so CH2OH will be above. Here also you have CH2OH. Rest everywhere it's hydrogen, hydrogen, hydrogen. So presenting you the structure of D-glucose. Because why it is D-glucose? Because I have told you in the second last carbon, when the OH is on the right, it means it is the D form. Okay, and if that OH was on the left, it would be L form. So guys, this is the structure of glucose, and also understand, because the OH on the first carbon is below, or you can say here it was on the right, that's why we call it as alpha form. Remember, there are two forms. There are any first carbon is basically the anomeric carbon, which is under the attack. So it can have alpha form also, and it can have beta form also. Anyways, that alpha and beta form, and D and L form, I'll put a different video on that. Okay. So until then, keep following Chakravi Science Academy for more such videos. So do share with your friends who may need it. Bye everyone.